In this video, we will be discussing how Python can be used as a calculator. Or you might have seen calculator, right? Which contains all the operators or the symbols like addition, subtraction, multiplication, division, and many more. So to use all those operators in Python as a calculator, you must be knowing the precedence and associativity. Associativity means the direction in a expression in an expression which contains all the operators. It may be addition, it may be combined with addition, multiplication, or even parenthesis. In such case you should be knowing which in which direction we have to evaluate along with which operator we have to evaluate. As I mentioned, you must be knowing about the precedence. Precedence means the priority given to each operator. For example, consider like in your expression, if you have addition and subtraction combined in a both, then which must be evaluated first? If you have even exponent combined, then which need to be evaluated first? So the precedence and associativity remains the most important when you are trying to evaluate any expression. Now, here in the table, we are seeing all the mathematical operators listed from highest to lowest precedence. In a simple words, we can call it as a priority. The first priority or the first precedence is given to parenthesis, and this parenthesis is evaluated from left to right. And whenever you encounter a parenthesis in an expression, you have to always first try to solve inside. You have to always try to solve the parenthesis. And after parenthesis, next what you have is exponent. You might be confused. This is a multiplication or exponent. This is an exponent. How it differs from multiplication is that exponent is always represented by double asterisk. So whenever you encounter double asterisk, you have to know that it is an exponent and it is evaluated from right to left, not from left to right. And third precedence is given to plus x and minus x, which are unary operators. These unary operators are just like positive and negative numbers in mathematics. Plus 5. Plus 5 means it is a 5. Minus 5 means it is a negative number, negative of 5. And they are evaluated from left to right. And coming to the fourth precedence of the operators, that is, here we have multiplication, float division, integer division, and modular division. So you might be wondering what are these. Multiplication, or everyone know that, which is used to multiply two operands. And next what we have is float division. Float division is something which will return me the entire quotient or the float quotient. Whenever I try to divide some number, and if it has a decimal part, if it has a decimal, then it will return me even the decimal part of the quotient. And next what I have is a integer division. Integer division is something which will return me only the integer part, and it will exclude all the decimal part. Consider like example like 10 divided by 3. When I divide 10 by 3 using float division, this will give me 3.33. It is recurring, so it will give me 3.33 as a final quotient. When I try to divide using integer division, it will provide me only 3, since it neglects or since it avoids the decimal part. Clear? You should be knowing the difference between integer division and you should be knowing the difference between float division and integer division. Yes, and next what we have is modulus remainder. You might be wondering, this looks like a percentage symbol. Of course, it looks like a percentage symbol, but here in programming we call it as a modulus remainder. Modulus remainder will return the remainder once you divide. Clear? For example, 10 divided by 3. As I mentioned, when I try dividing using float division, then it will produce me 3.33 as a quotient. For integer division, it will produce me only 3. Similarly, when I divide using the modulus remainder operator, it will provide me the remainder. So 10 divided by 3 is the remainder is 1, and it is evaluated from left to right. All these four operators, they may be arranged in any order. Like either in your expression you may encounter first modulus division or integer division. You have to always follow this associativity, that is from left to right. For example, on the left hand side, if you have modulus operator and then followed with multiplication, then modulus need to be evaluated, and then followed by the next operator. Clear? And coming to the last operators, that is addition and subtraction. Addition and subtraction are given the addition and subtraction are given the least priority, and they're evaluated from left to right. So, so except exponent, all the operators are abbreviated from left to right. Don't get confused between exponent and the multiplication. The first priority is parenthesis followed by exponent, and then we have unary operators. And next we have multiplication, float division, integer division, and modulus remainder. And the last is the most basic operators, it is addition and subtraction. And only for exponent we have the associativity as left, right to left, and the remaining all associativity as from left to right. Clear? Now let's move on how these operators work. Here you are seeing this is one of the most basic example. Print 5 plus 3. Here we have only addition, so we no need to follow any precedence or associativity, or even if we follow associativity also, like we get the same result. Clear? So when So since we are not following any precedence here, 5 plus 3 output is 8. Similarly for 10 minus 4, here we are subtracting. So the output is 6. And for multiplication it is 6 multiplied by 7, it is 42. Next, coming to division. Now try to differentiate in division and integer division. Uh, this can be also called as a division or float division. This is not an issue. 15 divided by 3. 15 is a whole number, right? So it is completely divided by 3 and it produces the quotient as 5. When I try to divide 23 divided by 7, since 23 is not divisible by 7, it will produce me a quotient with some float, float part. Clear? That is 3.28 and so on. And next, integer division, what we have is when we try to divide 23 and 7, it is giving me only 3 since it is a integer division. Here it neglects all the decimal part. After decimal we have 2857 and so on. Here when I try to divide using integer division, it will produce me only the whole number and neglecting all the decimal parts. Clear? And next what we have is exponent. You might be confused. The multiplication and exponent looks same. That is totally different. Here 2 exponent 3, you have to always pronounce it as 2 exponent 3, not like 2 multiplied by 3. That is wrong. If in case of multiplication I can tell it as 2 multiplied by 3, just I can tell like 6 multiplied by 7. But here since it is an exponent, I have to pronounce it as 2 multiplied by 3 and the output is 8. And next what we have is modulus remainder. Here it is producing me a remainder 10 modulus 3, that is output is 1. That is the remainder. And the output what you are seeing, it is a remainder, not a quotient. Let's take one of the complicated example where the operators are combined. Here in the first expression we are seeing 4 plus 3 mod 2 or modular division 2 multiplied by 5. Now here we have to apply the precedence and associativity for all the operators. As we know from the list, parenthesis has the highest priority or the precedence followed by exponent. But we don't have parenthesis and exponent in the in this expression. And next what we have is unary operator, that is plus x and minus x. Even we don't have plus x and minus x. After that we have multiplication, float division, integer division and modulus remainder, which are abbreviated from left to right. Here we have encountered with modulus division and multiplication, and it need to be abbreviated from left to right. From left to right, I can see 3 modulus 2 multiplied by 5. So I will evaluate from left. So what is there here? Modulus. 3 modulus 2, since modulus returns me a remainder, it is 1. 3 modulus 2 is 1. The initial operand, that is 4 plus, can be remained same. You can just differentiate or you can just currently ignore it since we are not considering addition at a time. So 3 modulus 2, which will give me a remainder as 1. Next, multiplied by 5. You can keep multiplied by 5 as it is. Now you try to now you try to solve what is solve for multiplication, since we have solved for modulus remainder. Now 1 multiplied by 5 is 5 and 4 plus 5 is finally 9 as expected. So this is how the precedence and associativity works. And next what we have is print 10 minus 3 plus 2. Here addition and subtraction has the least priority and they are evaluated from left to right. So from left we have 10 minus 3. 10 subtracted with 3, it is 7. 7 plus 2 is 9. And here print 2 exponent 3 exponent 2. Exponent has the second highest priority and it is evaluated from right to left, not from left to right. So from right I have 3 exponent 2. Clear? From right I have 3 exponent 2. So 3 exponent 2 means 3 multiplied twice, it is 9. Now the only expression left out is 2 exponent 9. 2 exponent 9 is 5, 1, 2. Clear? You might be getting confused. As I told you, it is evaluated from left to from right to left. It is 2 exponent 3. No, it's completely wrong. From right we have to follow. But whatever operators we are evaluating, that need to be evaluated from the beginning. It is 3 exponent 2, which is 9. Then 2 multiplied 9 times, or 2 exponent 9. It is 5 and 2. Now take this expression 2 plus 3 exponent 2 integer division 5 modulus 3. As we all know that anything inside the parenthesis need to be evaluated since parenthesis has the highest priority. So write down the expression clearly so that it will be clear for you while solving. Now what I'll do, I will try to solve whatever is there in the parenthesis. Yes. So what we have inside the parenthesis? Inside parenthesis we have 2 plus 3. So what is 2 plus 3? 5. I'll make a note of it. That is 5. So finally the parenthesis has been solved. Now the remaining expression can be noted down as it is, since we are not giving priority for it as we have parenthesis. Now after solving inside parenthesis, make a note of the remaining expressions. That is 5 5 exponent 2 integer division 5 modulus 3. Now as we all know that exponent is given the second priority after parenthesis. So 5 exponent 2 is 25. Next, the remaining what we have is 5 modulus 3 with integer division. Now integer division and modulus has the same priority and they are evaluated from left to right. So 25 integer division 5 gives me a 5 as a quotient. And the remaining expression left is modulus 3. 5 modulus 3, which will return me the remainder as 2. So finally the output for this is as expected, it is 2. Clear? This is how it works. Now let's move on to VS Code. So hope this is visible for you, right? Here what we are trying to do, we are trying to print 15 divided by 3, which will return shift and enter. Yeah, here you can see 15 divided by 3 is 5 because it is giving me a float division. And similarly, like if I try to print 16 divided by 3, then this will return me something else. What I have done, shift enter. Yes, here you can see print 16 divided by 3. Since it is a float division, it is returning me the integer division part. You can ignore this output 5.0 since it is a commented. Like whenever you see any lines with comment, with this comment symbol, it means that those lines are ignored, they are not considered for the execution. So 16 divided by 3, it is returning me 5.33. And next what we have is print and next what we have is print 23 divided by 7, and it is returning me 3.2871 since it is a float division. Similarly, when I try to divide 23 similarly when I try to divide 23 and 7 using integer division, it will return me the integer quotient. Clear? That is 3. You can see the difference between here. You can see the difference between the integer and float division here. Here integer division is giving me only the integer part, but here the float division is giving me entire the float entire the decimal part, and here it is ignoring all and giving me only the integer. Clear? And here we have print 2 modulus 3, which is a exponent, sorry, 2 exponent 3, and it means that 2 is multiplied 3 times, results 8. And this is the expression which I and here we have 10 modulus 3. 10 modulus 3 will return me a remainder, that is 1. And here we have expression which is combined with all other operators. Shift enter. So now what happens, like how this works is I already explained from the slide, but let me tell you clearly. Since we have modulus, you can just make a note like this. 4 plus mod, we have modulus operator and exponent and multiplication operator, which are evaluated first. Modulus and multiplication are evaluated first, and the first highest operator is parenthesis followed by exponent and unary operators, but they are not present in our expression. So 3 modulus 2 is 1, and the multiplication symbol will be as it is, followed by 5. Clear? And next what we have, 4 plus, among addition and multiplication is given the most priority. So 1 multiplied by 5 is 5, which is equal to 9. 9. And here you are seeing the output is 9, which is as expected. And try to execute 2 exponent 3, 3 exponent 2, which will produce me the output as 5 1 2. As I mentioned, it evaluates first 3 exponent 2, which is 9, and then followed by 2 exponent 9, which is 5 1 2. And similarly, now let's try solving this. Yes, now let's try solving this. And whenever you want to include comments, please make sure that you use the slash symbol, so that all the symbol lines will be excluded from the execution. Here we have parentheses combined. Clear? So first we have to try to solve what is inside the parentheses. 2 plus 3 is 5, right? Now make a note of the remaining expression as it is. 5 exponent 2, integer division 5, mod 3. Clear? This is how the expression got evaluated. Now after parenthesis, the next priority is given to exponent. So 5 exponent 2 means 5 multiplied 2 times. It is 25. 25 integer division 5 mod 3. Now we have exponent and, sorry, not exponent. Now we have integer division and modulus remainder. So we have to go from the associativity, that is from left to right, as you are seeing. The associativity for parenthesis is left to right, and also for exponent it is from right to left. If I had any other expression along with this, then that will be the other case. But here we have only one exponent operator, so it is 5 exponent 2, which is 25. Now after that we have integer division. So 25 integer division 5, which will give me the integer quotient, that is 5. And next what we have is modulus 3. 5 modulus 3, which will return me a remainder as 2. Now try to execute it, which is a 2. Now try evaluating the expression in different way. Yes, here you are seeing it is 0. As we followed the precedence and associativity for the operators, hence the expected output is 0, and our calculated output is also 0. So this is how the operators works with precedence and associativity. This is one of the most important thing, like whenever you are trying to divide using the positive and negative number, the output may differ. Here we are seeing. I'll explain how it differs. Here we are dividing and 10 integer division 3, which gives us 3, because 10 divided by 3, the floor value or the decimal part has been ignored, and this is a positive number. 10 is a positive number, and when I try to divide a negative number, that is minus 10, that is minus 10 divided by 3, that will return me minus 4. So what happens in case of negative numbers? Instead of rounding off to minus 3, Python will round off to the next whole number if in case of negative numbers. So the answer is -4, not -3. Clear? So do not get confused between positive and negative integers when you are trying to divide. So let's see even this, how it works. Print 10 divided by 3, which is a positive number, right? Now try to execute it. Here we see it is +3. And similarly, when I try to divide the same but with a negative value, now this will round off to the next integer value. It didn't execute. Yes. Oh, it didn't even print. Control, yeah, -10 and select it, shift enter. Yes, here you are seeing it is -4. Not only this, even considered like any of the negative expressions. So even in this case, it is -4. When I try to divide it, it is again the positive number, that is 3, as you are seeing. Because the next whole, it will round off to the next whole number. Clear? You can just make a note of this. 10 divided by 3. The actual quotient will be written as 3.33. Here you are seeing. When I am trying to divide, it is written with the quotient, and the next whole number, when I try to divide with a negative, it is -4. So whenever you are trying to work on the negative integers, it will return you the next, it will round off to the next integer number. Clear? So you can try solving this and let me know in the comments if you find any error, or if you're or like if you're facing any problem while solving. So do not directly open your Python editor and start doing. That's not a right way. So try to solve on your own, and for the answers you can check your editor. Clear? So if your answers are fine, then it means that you have understood, or else you have to remind again the precedence and associativity. Mainly we do mistakes there itself, right? So see you all in the next video. Bye bye. Take care.